few here or there. I'm not going to do all of these. I'm going to leave you guys to do the rest. So let's start with this first question. Okay. It says, what is the smallest positive integer value for x such that the value of f of x equals 2 to the x plus 1 exceeds the value of g of x equals 6x plus 10. Now, it would be easier to do this on Desmos where you could graph both of these, and we're going to look at some where we are going to do that. But I have seen these questions time and time again on the calculator inactive section. They like to put them on the calculator inactive section as well. So, what we can do for this, whenever we have a problem like this, is we can make us a table and look at what we would get if we plugged in numbers. If it's on calculator inactive, it's probably going to be fairly small numbers where this happens. If it's on calculator active, it might be huge numbers, and we're going to need to graph it. But so this is what I'm going to do. I'm going to make myself a table that's got 3 pieces here. I'm going to put my x right here, and then I'm going to do an f of x and a g of x. Okay? So it says, what is the smallest positive integer value for x such that the value of f of x exceeds, what's exceeds mean? Goes past or higher than, right? Higher than. Or greater than, right? The value of g of x. So we're looking for the first time f is higher than g. We know it needs to be a positive integer value, but to know kind of where we're starting from, I'm going to plug in 0 to both of these. I know 0 is not going to be my answer because it's not positive, but that kind of gives us where we're starting from. So if I plug in 0 here, what is 2 to the 0 power plus 1? It is 2. Very good. Because 2 to the 0 is 1. Very good. A lot of people would say 1 for that instead, but that is correct. That is 2. And then g of x, if we plug in 0 here. This is 6 times 0 plus 10. 10. Okay. You got the hard part right in the Alright. So then if we plug in 1. Okay, we got 6 times 1. Oh wait, I'm plugging in the wrong thing. 2 to the first power plus 1. What's that going to give me? 3. So I got 3 here. And then I've got 6 times 1 plus 10 over here. And that's going to give me 16. So we can see f is lower than g here. We're looking for the first time that f becomes bigger than g. So I'm going to start work on, so like if I plug in, I'm going to work on g of x. If I plug in 2, I got 6 times 2 plus 10. That's going to be 12 plus 10, 22. What's happening each time here for g of x? It's increasing by 6. So for like 3, I would have 28. And for 4, I would have 34. And for 5, I would have 40. And there's not nearly enough room on this worksheet, is there? 6, I would have 46. And maybe that'll be far enough, I hope. We'll see. All right, let's do a couple more here. If I've got 2 to the second plus 1, that would be 4 plus 1, which would give me 5. And then if I had 2 to the third plus 1, what is 2 to the third? 8. And plus 1 would give me 9. So that'd be 9 right here. 2 to the fourth plus 1 would be 16 plus 1, which would give me 17. This one's not as easy to see a pattern. There is one. But we can just keep doing what we're doing. 2 to the fifth plus 1. What's 2 to the fifth? 32 plus 1 will give me 33. Okay. 2 to the sixth plus 1. 65. Oh, there we go. Okay, so what is the first time that our f function, first integer, what's integer mean? Whole number and the negatives, because technically whole numbers do not include negatives. That's not really important here. They could have said whole number, but they know that some people don't know that that means it must be positive. So first whole number where f is bigger than g is going to be at 6. So our answer for this one right here would be 6. Okay, so you have a few more questions that are similar to this. 3 is a little bit different. Let's just look at it together. It says, write an inequality that shows the values of x for f of x equals 6 to the x plus 2 will exceed the values of x for g of x equals 12x squared minus 4x plus 10. So we're wanting to know when f exceeds g. Exceeds, we just said, that means higher than or greater than, right? So this is just wanting you to write the inequality. You're not solving it. So if we take f, which is 6 to the x plus 2, we would say it's greater than 12x squared minus 4x plus 10. And we don't know how to solve that. In fact, I don't know how to solve that without a calculator anyway. So it's not really asking you to solve it. It's just to set it up. Two and 4 are going to be more like number 1, where you're going to make yourself a little table for that. Yes, you're welcome to use the whiteboard, especially for those tables, because they don't fit there very well. But let's do some that require a calculator here first before we work on those others. So, all right, so let's look at number 5. Number 5 says you are comparing the graphs f of x equals x to the 4 to the x and g of x equals 64x squared minus 16x for different values of x. Write a statement that best compares the values of the functions as the values of x increases. Will the y values of one function always exceed the other? Will it occur at a certain x value? So for this one, we are going to use Desmos, so let me split screen here so we can see it. And we're just going to type in our 2 equations. And you can type these in for yours as well so you can see it. Because I do want you to see something about this. I want you to make sure you can get a good picture. Everybody type yours in for number 5. Okay, so really we're talking about which function is bigger here. Which function is bigger? How on the graph can I tell if a function is bigger or has a greater value? What does it look like on the graph? It's going to, for most of these, it's going to change, right? It's not always going to be the same. So, for example, if I look right here at this point right here, which function is bigger at that point, the quadratic or the exponential? Not. Which one of this is quadratic? Is blue quadratic or is red quadratic? Blue is quadratic. All right. Now, whenever I look at this point right here, okay, which function is the top function right there? Which one's higher? It's the exponential. It's above the blue. But over here, like right here, part of the reason we also can't see is because our picture is not great. Because I can't really see the blue right there. But just based on what's happening here, that blue should keep on going up. So maybe here at 1, then my blue graph is actually higher than my red graph. So let me stress to you, it is so important, you cannot just zoom out on these. See what happens if you zoom out? It looks like an L. The red and the blue went together. I can't tell what's happening there. So on these problems, you cannot just zoom out. So here is a fact that you need to know. Exponential growth is going to eventually grow faster than any other type of growth. So right here, this blue graph is much steeper than our red graph, right? This blue graph is way higher than our red graph over here. It's very steep. That blue graph is our quadratic. So it's going to look like it's really going up really fast at the beginning. But eventually, if you go out far enough, an exponential is going to grow faster than any line or any quadratic. So what that tells me is if I'm comparing an exponential and a quadratic, the exponential eventually should be biggest. Okay? Exponential eventually is going to be bigger. We did this with a problem where it was where I told you that like your grandpa was going to pay you like $15 an hour or $15 to mow your yard every time, or he'd pay you 1 cent the first time, 2 cents the next time, 4 cents the next time, and 8 cents. You know, like double the amount that he pays you every time. And so, do you guys remember talking about that problem? What happened? Right, the 1 cent added up a lot more, right? Because at first you were, now if you were going to mow your grandpa's yard twice, you were better off taking the $15 for each time, right? But as it went on, you kept getting paid more and more and more and more and more to where you made a lot more. I think we were up to like $1 million for this lawn mowing when we got to like 30 or 40, right? It was huge. So it grows really fast in the end. That is always going to happen with exponential. So most of the time when you graph these, you can't see what's going on. Do not zoom out because you will lose what you're trying to look for. Hit the wrench button. Change your Y. Okay, so I'm going to try 100 and see if that works. Not really, because what I should see is this red should cross this blue again. So 400. That's getting closer. Sometimes what I'll do is I'll just go over here and I'll do 100 and I'll put another 0 till I see it do something like that right there. The problem with this is you can't really see what happens down here, so it is important to see down there too. Let me go a little bit lower. Let's see if you can see. Oh, not 100,000. Let's see if you see that there. That's pretty good. 1,000's pretty good. Or 2,000 there. So now, when I'm looking at this, there was actually just a little tiny sliver of time where f of x was below g of x, where the quadratic was below. I'm going to hit the house button in a second, but right now, right here at this point, after x equals 5.398, then notice that the red graph switches to being on top. And that's going to be the case for the rest of eternity to infinity. So we could say something like this: for x is greater than, what was that number again? 5.398. F of x is greater than g of x. Now, this problem is a little bit weird because there is actually one other time that also happens, because it's a little bit weird. When you're zoomed out like this, it looks like these just barely touch, but they actually, we know because when we were at our home screen we could see it. If I go back here, that also happens here. Also for negative 0.049 less than x less than 0.325. So it's also true for that little section as well. Yes. Hello? Hey. Yes. Uh-huh. Okay. Yeah. Yeah, I think so. I don't think so. Oh, because I wasn't. Yeah. I mean, I can do whatever they want me to do. I did not ask for it. Yeah. 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 I think that would be good. All right. Okay. All right. Sounds good. Okay. Thank you. Bye. Okay. All right. So, all right. Let's look at number 6. Okay. Number 6 wants us to use the table, and this is one of the last ones that you can't use your calculator on. Use the table to create functions for f of x and g of x. Once you have created the functions, that we have to write a statement that is true about the two functions when the value of x is negative 5. So we've got to write equations for these two things, right? And we'll talk about a way to do it with a calculator, but first we need to look at how to do it without a calculator. First of all, it's very important that we know what's exponential, what's quadratic, and what's linear. Okay? So looking at these two functions, one of them is linear. Which one is going to be linear? Okay, it's going to be g of x. Yep. So this one is linear, and I know it is linear because it's going up by the same amount. Over here we're going up by 2, 2, 2, 2. And over here we're also going up by 2, 2, 2. So that means my slope, or my change in y over change in x, is going to be 2 over 2, which will give me 1. So g of x, I know I'm going to have a slope of 1, so I'll be next to my x. You don't have to write that 1 if you don't want to. What else do I need to write the equation of a linear equation? It's y equals mx plus b. The b stands for the y-intercept. Do I have the y-intercept? The y-intercept is where what? Equals it. X equals 0. Is that on our table? Yes, it is. X equals 0 right here. 8 is our y-intercept. Okay, so we can just put plus 8 right here. That's our equation for g of x. You can test it by plugging in some numbers. Like if I plug in negative 2, 2 times negative 1 is negative 2 plus 8. That'll give me 6. All right, you can test it by plugging in some numbers. So that one we've got. What do we think about f? Is it linear? Okay. How are we going to tell? How are we going to tell if it's exponential or quadratic? Because that's difficult. If you go from the bottom to the top, you're multiplying by 4. What about if we go from the top to the bottom? We're dividing by 4. But I would like for us to be multiplying instead. So what's the same as dividing by 4, but multiplying? Multiplying by 1/4. So we're taking a fourth of this, and then a fourth of this, and then a fourth of this, but we're multiplying there. And so when you are multiplying by something, it may look like division sometimes, but just remember, like if we're dividing by a number, we could multiply by 1 over that number and it'd be the same as division. So if you're multiplying each time, that's exponential. So for exponential, that is the a times b to the x power. The a is our starting value, or our y-intercept. What is our y-intercept for the exponential? It is 1. What is our, and then our b is that number that we're multiplying by each time, right? So that is our 1/4 to the x power. So it asks us to write the equations first. Are we okay there? Okay, and then it asks us to compare them whenever x equals -5. So I just need to plug in -5. So I'm going to have g of -5 here. I'm plugging into this one first because it's a lot easier. So this is -5 plus 8. We're going to get 3 there. So whenever you plug in -5, you get 3. That means the point -5, 3 is on that graph. All right, this one's not as easy. That one we don't really have to write. F of -5 is going to be 1/4 to the -5 power. This is a little exponent rule practice here. What do we do with that exponent? Okay, we could move it to the bottom. Then we're going to have like 1 over a fraction. I really don't like that. Or what we could do is we could like distribute this to the top and the bottom. So we've got 1 to the -5 over 4 to the -5. And then I could flip it. That way I avoid having like a fraction inside of a fraction. So then I could do 4 to the 5th power up here and 1 to the 5th power down here. 1 to the 5th power is just 1. 4 to the 5th power, good gracious. Okay, this is we get to use our calculator a little bit on this. What is 4 to the 5th power? It's not over 10. It's just 1024. So we would get 1024 here. Okay. Questions? Okay, this goes a little bit into what we're doing tomorrow, but let's look at 7 and 8, okay? First of all, 7 says to determine if each function is linear, quadratic, or exponential. So look at those numbers. I want you to decide on your paper which one's linear, which one's quadratic, which one's exponential. There's one of each. Okay, what do you guys think? Aiden, what do you think? Give me one of them. Linear, quadratic, or exponential. You can give me any of them. Which one do you think? It is. Very good. Okay, because you're going up by one, you got times 2 each time, right? You're multiplying each time, so that's great. All right, Evan, give me another one. Okay, f of x is linear. We can see that this is linear because we're just going up by 12 each time. So Isabella, quadratic in the middle here. Quadratic is the most difficult. Yeah. Well, you're right. It's not hard since we've already, but quadratic is difficult if you don't know for sure there's one of each. So quadratic, you can see this goes up by 13, and then the next one is going to go up by 15, and then the next one goes up by 17. So I showed you this the other day because I told you I just have learned this year. I've been teaching math forever, and I just have learned this year. That is not constant, but if I do it again, 13 to 15 goes up by 2, and 15 to 17 goes up by 2. If that happens, you're looking at something that's quadratic. So it's not that difficult to narrow it down to which one has to be quadratic, but if you were given that table alone, it might be hard to tell that it was quadratic. 8 has the exact same numbers on it. For 7, it's just asking which one's linear, exponential, quadratic. 8 has the exact same numbers, and it is going to ask us to write an equation of the line. Okay? So we can do this by hand or using the calculator. So I'm going to kind of run through how to do it with a calculator. By hand, you're looking for slope and y-intercept for your line. You're looking for starting value and the multiplier for your b. So we could come up with those fairly easily. But you also have the option. You got 0, 1, 2, 3. And then I'm going to put in my numbers, 6, 18, 30, 42. I'm going to do another one. I got 0. Hold on. Why is that not showing up? I'm going to do full screen. Y2. Alright, and I got 0, 13, 25, 38. Is that right? Relying on my memory here. And then Y3 is going to be 1, 2, 4, 8. Okay, so it is very helpful to know which one is which, linear, exponential, quadratic, before you try to do this. But a linear graph is y equals mx plus b, right? So if I want the calculator to figure it out for me, my linear is in y1, so I'm going to do y1 squiggle mx1 plus b. Okay? And it gives me m and it gives me b. Okay? So, we will have, let me call it f of x. For f of x, yes. I typed it in wrong and it didn't stop me. Thank you for stopping me. Okay, there we go. That's better. Alright, so f of x is going to equal 12x plus 6. And that should make sense because you're adding 12 each time, and the y-intercept would be 6. Okay? It found the slope and the y-intercept for me. Okay? Now that was for y1 because it was linear. I'm going to skip over to 3 because I think we did it in that order. So because I'm using the third line right here, I want to say y3 instead of y1. Okay? And I'll do squiggle. And I said this one's exponential. What was our form for exponential? A times b to the x power. And we're going to still put a 1 with our x because our x column just has a 1 right there. So if I do that, I know h of x is going to equal 1 times 2 to the x power, which is really just 2 to the x power there. All right, that leaves us the middle, the y2. All right, what was our form for a quadratic? Didn't have m and x. We used the a, b, and c. We talked about it when we did that negative b over 2a. We really didn't do regressions with this one, but it's going to be ax squared plus bx plus c. We did not do, now it's got a problem here. What did I do? No, my a, b, and c are fine. My x is not my table. I need a 1 behind my x's. I should be doing x1. All your variables, your x and y's, have to have subscripts to be able to do this. So it gives me a equals 1, b equals 12. C is actually 0. So g of x would equal x squared plus 12x plus 0 if you want to put it on the end, but you don't have to do that. We didn't do these quadratic regressions in class, so that's kind of new. But ax squared plus bx plus c, that will really help you because otherwise you're going to have a hard time writing that equation right there. And now it wants to know what has the greatest value whenever x equals 7, so we don't have time to do it, but what will we do? Just make x equal 7 in all 3 of those and see which one's the highest, okay? All right, so you've got several left to do. I want you to do those tonight, and then we'll talk about them tomorrow, okay? You may use your calculator on all of them left except for the ones at the very beginning where we did those, okay? So let the graph help you on those.